So in this question, we're given a hash table that takes key value pairs and stores them in a hash table with external chaining. And the keys in this problem are all strings, and the hash code for each string is its length. We're asked to do two things. First, implement the hash function hashfunc, and two, complete the method insert. It inserts new key value pairs into the hash table. We'll be implementing the part of insert that handles resizing, but we'll be doing it recursively. So to start off, we first have this hash node that we use to make these external chains. Now, this hash node, as you can see, consists of a key, a value, and a next pointer. So here is my visual representation of this hash node. I'll use K to denote key, B to denote value, and I'll use this dot to represent our pointer. If the hash node is alone by itself, then the pointer simply points to null. But if the hash node is paired with another hash node, one that's defined and is not null, then it will simply point to a new hash node. And the new hash node, excuse me, the new hash node will have its next pointer pointing to null. Here we're given the class of the actual hash table, and we can see these instance variables being initialized. Here we have a hash table, which is simply an array of hash nodes. And then we have the integer for the number of buckets we have, one for the number of elements we have, and a number for our max load. In this case, our max load, which is our load factor, is 0.75. Now here's our constructor, where we set the number of buckets to 10 initially, and at the beginning we have 0 elements. Now using the number of buckets, these 10 buckets, we initialize the hash table array so that it's an array with 10 elements, each element representing a bucket. This part is somewhat redundant, but for the sake of this question, we'll go with it. So here in this for loop, what we're doing is in our hash table, for each element, obviously this is not to scale, and not every element is represented in this hash table, but here what we're doing is we're setting each to the null pointer. Of course, it's redundant because this happens anyways when we create an empty array. So the first part of this question is filling out this hashfunc method, and it's given a key, return the hash code for that key. So in the problem description, we're told that the hash code for each string is its length. So this hash function should return key.length, but say if the key has a length that's somehow greater than the number of buckets in our array, so the number of buckets or we might denote this as m. Let's say m is, well, how many are here? 2, 4, 6. So there's 5. There's 6 buckets here, and we index from 0 to 5. So let's say key.length is 7. So if key.length is 7, then that means we'd return the index. Well, we have an overflow from 6 buckets. We'd have to get the index 1. So what this means is when we have this overflow, we handle it by taking the modulus. In this case, we take the modulus of the number of buckets, and written mathematically, this might say key dot length mod m. Now, part 2 of this question asks us to complete the insert method, in which we insert a key and its paired value into our hash table. So you can see we begin by getting the index from our hash function from earlier, using this index to obtain a hash node from the hash table, this hash node being the first hash node that we see in the hash table at that index. And then we have some certain cases. So first, we check if the key is already in the table. So if the key is already in the table, then we see that if the key of the head that we had found from our index, if that hash node's key is equal to the key that we pass in to our insert method, then we reassign that hash node's value as the value that we pass in to our insert method. It might be better to visualize it like this. So we have our array. Of course, not all elements are represented here. 0, 2, 4, 6. So 0 to 5. Let's just say, for example, this index turned out to be 1. So we have our head here, our head being the hash node spot, the first hash node we see, and maybe it's a chain. And so we have multiple hash nodes, one linked after the other. And of course, we end at null. And here we have the case in which we resize. And we know we do this if we find that m, or rather n, which is the number of elements, when we insert a new key divided by m, which we have already established as the number of buckets, is greater than our load factor. So if this inequality is true, then we go ahead and resize. And I'll come back to that later. Afterwards, whether or not we resize, we go to these set of lines in which we add a new key and value as a hash node. And so we see that here we increment the number of elements because we've added a new element, and then we find the index for that key. We find the hash node head for that index in the hash table. We create a new hash node called new node. Let me go back to this line right here. Hash table index, which is this hash node right here called head. And here in our next pointer, I'm going to say this points to ellipses, which simply means multiple hash nodes, or maybe a null. And then we have this new node. So new node. And right now we have this next pointer. I'll refrain from defining it for now. In this line, we see that new node.next is equal to head. So here we're assigning our next pointer to head. And then hash table index is assigned to new node. So this pointer from hash table index to head is now reassigned to new node. And so we see that when we add a node, we put it in front of the existing head or the existing chain at that index. And so to return to this resize function, given that we know this insert method has given us some code to check if a key is already in the table, and some code to add a new key value pair as a hash node. So to start off, we have this first line. Of course, this has to be this inequality, n over m is greater than load factor. So let's just define terms real quick. Of course, n is equal to the number of elements when we insert a new key. So the number of elements plus the key that we're about to insert. So plus 1. And so m, of course, is the number of buckets, or should I say num buckets. And our load factor is equal to max load. Now, putting this together, we find that num elements plus 1 divided by num buckets is greater than max load. And I'll put this here in a sec. Now, to make this all work out, we first have to realize that in Java, an integer divided by an integer is equal to an integer, and a double divided by an integer is equal to a double. So in this case, we have to cast num elements plus 1 to a double. Now, the new number of buckets we have is defined by what was described in the problem. If we go earlier to 3.1, we see that resizing doubles the number of buckets. So in this line over here, we find that the number of buckets is equal to itself divided by 2. And in these two lines, we see that we are copying this hash table into this temporary variable called temp. Well, we're creating this new hash table, which is a new array of hash nodes for our newly defined number of buckets. And so because of the new hash table, and we haven't added anything to it yet, it has 0 elements. Now, if you notice, these 4 lines, or perhaps 3 of the 4 lines, are similar to this constructor over here. And this is because this constructor is where we create a new hash table. And so to continue mimicking this constructor, we'll create these empty chains from this for loop in this for loop. So here we assign each element of this hash table to null, and thus creating our new and empty hash table. Oh, bit redundant, of course. Now in this last part, we look to copy the nodes from our old hash table to our new hash table. So of course, in this top for loop, we're going to take the hash nodes at each element of our old hash table, which is now in temp, and we'll copy each of the nodes in the chain. So if we want to take this array, for an example, at this index, we want to copy this key and this value, and this key and this value, and this key and this value. So we want to iterate through the chain at each element, at each element. So this means that we iterate by constantly reassigning head node to the node it's pointing to, In other words, head node.next. And we see that we stop at a value null or a null pointer. Null is where the list stops or the chain stops. So we can only iterate through the chain so long as head node is not equal to null. Then, of course, we want to add the values, the value of each head node into our new hash table. So to do that, what we do is we can reuse all of this code. So this code and this code. So we call insert head node dot key and head node dot value.